Hey everyone! Today, we're going on a journey through time. A journey that will take us billions of years into the past, to the very beginnings of our planet. We're going to be exploring the incredible geologic time scale, a tool that helps us understand the vast history of Earth and the life it has supported. So, strap in and get ready for a thrilling adventure through time. Now, you might be wondering, what exactly is the geologic time scale? Well, it's a way for us to break down Earth's 4.6 billion year history into manageable, understandable segments. The geologic timescale is organized into eons, eras, periods, and epochs, each representing a significant chapter in Earth's fascinating story. But why is it so important for us to understand Earth's history? The answer is simple. By studying the past, we can gain invaluable insights into how our planet has evolved, and how life has adapted to survive and thrive in an ever-changing world. By learning about the incredible events that have shaped our planet, we can better understand the forces at work today and make informed decisions about how to protect and preserve Earth for future generations. So, as we embark on this incredible journey through time, we'll uncover the secrets of Earth's past, from its fiery beginnings to the rise of complex life and beyond. By exploring the geologic timescale, we'll not only gain a deeper appreciation for the world we live in but also learn vital lessons that can help us safeguard our planet's future. Stay tuned for more exciting insights into Earth's history, and don't forget to like, share, and subscribe for more fascinating journeys through time. Imagine the early solar system, a swirling mass of dust and gas, slowly coalescing into the celestial bodies we know today. Around 4.6 billion years ago, Earth began to take shape as gravity pulled these particles together, eventually forming a hot, molten mass. As our young planet continued to grow, it experienced intense heat and pressure, causing it to separate into layers, the core, mantle, and crust, a process known as differentiation. Now, let's fast forward to the Hadean Eon, which began around 4.6 billion years ago and lasted until about 4 billion years ago. This eon is named after Hades, the ancient Greek god of the underworld, reflecting the hellish conditions that prevailed during this time. Earth's surface was a hot, molten sea of magma, constantly bombarded by meteorites and comets, making it a very inhospitable place for life as we know it. But amidst this chaos, something incredible was happening. As Earth began to cool, the molten magma on the surface started to solidify, forming the first primitive crust. This was a major milestone in Earth's history, as it set the stage for the development of continents and oceans. Speaking of oceans, the Hadean Eon also saw the formation of Earth's first bodies of water. As the planet's temperature decreased, water vapor in the atmosphere began to condense and fall as rain, filling the low-lying areas of the newly formed crust. Over time, these bodies of water grew larger and more abundant, eventually giving rise to the vast oceans that cover our planet today. The Archean Eon began around 4 billion years ago and lasted until about 2.5 billion years ago. During this time, Earth's crust continued to cool and solidify, and the planet's first continents began to form. The oceans also became more established, setting the stage for life to emerge in these ancient waters. And emerge it did. Around 3.5 billion years ago, something truly remarkable happened. The first signs of life appeared on Earth. These early life forms were simple, single-celled organisms called prokaryotes, which lacked a nucleus and other complex cellular structures. These microscopic pioneers were the first living things to call Earth home and laid the foundation for all life that would follow. One group of these early life forms, known as cyanobacteria, played a particularly important role in shaping our planet's history. Cyanobacteria are photosynthetic organisms, meaning they can convert sunlight into energy through a process called photosynthesis. This process not only allowed them to grow and multiply, but it also produced a waste product that would forever change the Earth's atmosphere: oxygen. As cyanobacteria thrived in Earth's ancient oceans, they released oxygen into the environment, gradually increasing its concentration in the atmosphere. This influx of oxygen set the stage for the development of more complex, oxygen-dependent life forms, and ultimately led to the diverse and abundant life we see on Earth today. The Proterozoic Eon began around 2.5 billion years ago and lasted until about 541 million years ago. This eon was marked by significant changes, both in the development of life on Earth and in the planet's geological landscape. As we dive into the Proterozoic, we'll witness the rise of complex life, the first animals, and the profound impact of the first continents on our planet. During the Proterozoic eon, life took a major leap forward with the emergence of multicellular organisms. These complex life forms consisted of more than one cell, allowing them to develop specialized functions and more intricate structures. This was a game-changer in the history of life on Earth, paving the way for an explosion of diversity in the planet's ecosystems. Among these multicellular organisms were the first true animals, which made their appearance around 600 million years ago. These early animals were soft-bodied and relatively simple in structure, but they represented a crucial step in the evolution of life on Earth. In addition to these exciting developments in the biological realm, the Proterozoic eon also witnessed significant changes in the Earth's geology. During this time, the first true continents began to form, forever altering the planet's landscape. The development of these continents had a major impact on Earth's climate, oceans, and even life itself, as they provided new habitats for organisms to colonize and shape the planet's weather patterns. So there you have it, the Proterozoic eon, a time of monumental changes on Earth. From the emergence of complex life and the first animals to the development of the first continents, this incredible era laid the groundwork for the world we know today. Welcome to the Phanerozoic Eon, an awe-inspiring time period that spans from 541 million years ago to the present day. The Phanerozoic Eon is often referred to as the Age of Visible Life, because it encompasses the time when complex life forms, including those with hard shells and skeletons, began to thrive and diversify. This eon is divided into three significant eras: the Paleozoic, Mesozoic, and Cenozoic. The Paleozoic Era, which lasted from 541 to 252 million years ago, witnessed an incredible diversification of life, most notably during the Cambrian explosion. The Cambrian explosion, which occurred around 541 million years ago, saw the rapid appearance of most major animal phyla, forever changing the face of Earth's ecosystems. The Paleozoic Era also experienced several mass extinctions, with the most significant being the Permian-Triassic extinction event, which wiped out about 95% of marine species and 70% of terrestrial species. Next up is the Mesozoic Era, spanning from 252 to 66 million years ago. This era is often referred to as the Age of Reptiles, as it saw the rise of dinosaurs, marine reptiles, and flying reptiles like pterosaurs. The Mesozoic Era was marked by the continued evolution and diversification of life on Earth, but it came to a dramatic end with the Cretaceous-Paleogene extinction event, which led to the demise of non-avian dinosaurs and many other species. Finally, we arrive at the Cenozoic Era, which began 66 million years ago and continues to the present day. This era is known as the Age of Mammals, because it witnessed the rise of mammals as the dominant life forms on Earth. During the Cenozoic Era, many new mammal species evolved, including the ancestors of modern humans. This era has also seen significant climate changes and the development of our planet's modern ecosystems. Let's delve into the fascinating story of human evolution and our impact on Earth's history. Humans, as part of the Homo genus, are a relatively recent addition to the planet's long and varied history. The emergence of our species, Homo sapiens, can be traced back to around 300,000 years ago in Africa. From there, our ancestors began to spread across the globe, encountering and adapting to a wide range of environments. As humans expanded and developed more advanced technologies, our impact on the planet increased dramatically. From the domestication of plants and animals to the creation of complex societies and the Industrial Revolution, humans have left an indelible mark on Earth's ecosystems, climate, and natural resources. This brings us to the concept of the Anthropocene epoch, a proposed addition to the geologic time scale. The Anthropocene is a term that was first coined in the year 2000 by Paul Crutzen, a Nobel Prize-winning atmospheric chemist, and Eugene Stormer, a biologist. This proposed epoch reflects the idea that human activity has significantly impacted Earth's geology and ecosystems to such an extent that we have entered a new phase in our planet's history. The Anthropocene has yet to be formally accepted as a distinct epoch by the International Commission on Stratigraphy, the organization responsible for defining and maintaining the geologic time scale. However, the concept has gained considerable support within the scientific community and has sparked a robust debate on the extent of humanity's influence on the planet. In summary, the story of human evolution is not only one of our species' development but also of our profound and lasting impact on Earth's history. The Anthropocene epoch, as a proposed addition to the geologic timescale, serves as a powerful reminder of the responsibility we have to understand and manage our influence on this incredible planet we call home.